Alright, so now we're going to go ahead and take a look at the different, the way the hydrochloric acid works on a buffered and unbuffered system. So to start with, I've prepared a pH meter so we can keep track of the pH values. I've also got some pH strips that we'll be using to kind of go alongside our values from the pH meter. And I've got our beaker here, 250 milliliters, labeled for our buffer. So I'm going to add about 50 milliliters of our buffer. Now inside this I've also included a stir bar. I'm just going to turn that on so it keeps things mixed up. I'm going to pull out my pH electrode, and with a lint-free wipe I'm going to wash off the electrode. And then with a different one I'm going to dry it off. Now, on this electrode, you can see right here kind of a little dimple. That is a semi-permeable membrane. We need to make sure that when we put this into our buffer that is submerged. So, okay. So now we're going to let that take a read of the pH. Alright, so our pH reading has stabilized at 4.61. You can see that it's stable because the pH here is, there's pH letters here that are solid, not blinking. So let's also get you'll see I also changed the beaker out for a moment because I couldn't get the full submersion of the electrode. So we're going to take this pH strip, dip it in, pull it out, and we will see what it says. It can be hard to distinguish between different colors on this, but yeah, it looks like it's probably between 3, 4, get just a little, another fresh read on this. Yeah, so there's the color on that. So now I'm going to take about 5 milliliters of my hydrochloric acid and add it over. And I'm going to stir it again for just a moment. That should be good. And And that stabilizes pretty quick to around 4.45 or 4.46. We're going to call it 4.46. And now I'll add 5 more milliliters of our hydrochloric acid. Give it some stirring. And wait for this to settle out. Looks like it's settled again. So at this point we've added 10 milliliters of our hydrochloric acid solution and our pH is 4.31. So now that it's been steady at 4.31, we're going to add 10 more milliliters of our hydrochloric acid solution. And then we'll stir it. And now we'll wait for it to level out. And now we've added 20 milliliters of our hydrochloric acid altogether. And our pH is at 3.97. I think we can do one more addition to this beaker before we have to change back to the bigger beaker. So we're going to add another 10 milliliters of our hydrochloric acid to the buffer. Then we'll stir. All right, let's let this reading settle out. So it looks like we are sitting at a pH of about 3.34 after a total of 30 milliliters of our hydrochloric acid added. Alright, so we actually changed out the beaker here and the pH is up a little higher, so it's about 3.36 is what we're going to record. Now we're going to add 20 milliliters of our acid solution to the buffer. And then we'll stir. All right, we'll give this a moment to fix our pH. Actually, it looks like it's already there. So at this point, we've added 50 milliliters of hydrochloric acid, and we are at 1.73 on our pH. All right, in the last addition, we're going to do 50 milliliters of our acid to the buffer. And then we'll stir. Alright, I'll turn off our stirring now. Looks like our pH has settled. After adding 100 milliliters of our 0.1 molar hydrochloric acid solution to our buffer, we are at a pH of 1.31. I just realized I didn't take pH paper readings in there. We'll get one now. There's a pH strip reading of our solution. As you can see, the distinguishing the pH can be fairly tricky just using the pH strip colors. You know, it's very dark red at very low pH, but then like between 2 to 4 on the pH scale, it's really hard to measure. But let's see how this works with water.